We will get going right now. We do have a lot of people on the webinar today. Our presenter is Todd Mansell. He's an expert from Caterpillar. I've known Todd for many years now. I knew Todd in a previous life and now since he's at Caterpillar. So a little bit of housekeeping before we do kick it off with Mr. Mansell. If you do have questions during the presentation today, a couple of ways that you can put those in. You can hit the chat window, which is on my screen on the lower right-hand side, or you can unmute yourself and ask your questions if you would like to do that at the time. I will be monitoring that chat window while the webinar is going on, and I will interrupt Todd if the question at the time, or we can wait at the end and he will put up some time for questions and answers as well. So to get going, the reason that we are able to do these webinars at a no cost basis is because of our sponsors. You can see our sponsors on the screen, and we really want to thank them. A lot of them are national sponsors, but we do have local sponsors as well. Our great partners at the APWA Colorado and the Colorado Association of Road Supervisors and Engineers, as well as the Federal Highway Administration. We do get a lot of support from those three groups, as well as our industry and contractor partners, Defects, Black Magic, which are both BG chemical companies, Schmidt Construction Company, Colorado Springs and Castle Rock, Colorado Asphalt Services in Commerce City, Vance Brothers, A1 Chip Seal, and our local partners at MEGPEG, the Municipal Government's Pavement Engineers Council. So we want to thank all of them for their support in what we do here at the RMAEC and putting on these webinars. So with that said, Todd, I'm going to throw it to you and let you take over. I've given you control, so you can switch to your slides in the upper left there. There you go. And I'll mute out, but I'll be watching that chat window if anybody does have questions as we're moving along.
All right. Well, thank you, Tom, and thanks everyone for attending this morning, this afternoon, whatever time of day it is where you're at. I always appreciate the opportunity. So thanks again to all the sponsors for this as well, and the Pavement Association talking about matte defects today. So what I would like to get into is talking about understanding matte defects. So one thing that I always like to start off with on this topic is, how do I know if I have a matte defect? And to me, it's the obvious. So I'm looking behind the paver here as we're going along. On the left side, you see in that picture, it looks like a nice uniform textured mat all the way across from one end gate to the other. So that's kind of the very first thing I look at. And on the right side, you can see some texture differences in the mat, a line over towards the right. So immediately to me, that tells me, hey, I've got a matte defect here. So I look at it, and then the first thing that goes through my mind is, well, what happened? What's causing that matte defect? So this one just kind of a humor slide, if you will. Most of us have probably seen this before, when a truck rolls away from the paver and the mix spills on the roadway. But it's not only about identifying the matte defect and what caused it, but what will we do next? So that's kind of the gist of the things I want to cover here in the next hour or so. And it's by all means not all inclusive. So I'm covering a lot of what I think are kind of I'll call them the big things. There's a lot of other matte defects and causes that we may see out on the roadway, but I'm really focused today on just trying to hit the highlights. But we saw that last image. So if I spilled mix in front of the paver, what would you do next? Are you going to load that mix back in, send it back to the plant, spread it out, pave over it, make the truck driver buy us a case of beer? I don't know, maybe, maybe some of all of the above. But what problems do those spills cause? So again, that was a truck rolling away from the paver. There's other ways we can get these spills on the grade, but what do those spills on the grade end up, how do they end up becoming, or how are they a mat defect? So we've got that small compacted pile mix. In this picture, you can see it right in front of the truck tires. So whether it spilled out between the hopper flashing or around the paver on the last truckload, or it just got spilled out by a truck banging its tailgates, that thin layer of mix cools off right away, and we never get good compaction on there. There's a really good likelihood that that cold material, again, we're not getting density on it because it's cooling really fast. We may pave over it and it looks nice and we don't even see that matte defect on the surface. So the matte surface may look great. If I'm a roller operator on a steel drum roller, there's a good chance I'm going to feel that bump as I go over that material that spilled in front of the screed. There's also a good possibility, depending on the mix size and how thick a mat that I'm paving, that I may end up dragging aggregates or dragging rock, as we say. But what's the end result of these spills on the grade? They quite often become potholes, right? So ends up, when I see those spills and we pave over them, and again, the surface of the mat may look nice, but I call those the birth of a pothole. And that's what you're going to see in the mat down the road. You're not going to see it right after paving. And again, you're probably going to see an effect on your IRI or your smoothness results as well with those spills on the grade. Here's a picture just showing a spill paved over, and it's kind of dragging rock, if you will, as that screed goes over that high spot where that material spilled on the grade. So when will they show up? Again, it might be the day after, probably not the day after if you don't see it right away. It's likely to show up a year or two from now. Again, most likely in the form of a pothole. So trucks spilling, that was just one example. Can you think of other situations? So banging out truck beds. So I see this, I was just on a paving job right near home here in Minnesota, where I'm based yesterday. Went out to a commercial job and they were banging their tailgates out right in front of the paver and cleaning out their truck beds, leaving those little piles of mix on the grade. So what should we do? If it's already happened and it's there, probably the best thing we can do is pick it up and throw it off to the side and get it later. Most often I'll see people spread it out a little bit, labor or somebody on a shovel, kind of spread it out a little thinner in front of the paver. Not the best answer, but I guess better than leaving a big pile. In a perfect world, send those trucks over to a designated clean out area, somewhere we can just dump that or bang out our tailgates or clean out our truck beds off to the side, especially on these highway jobs. So we can go clean out an area. What do we do at the end of the day? We can, if we've got a skid steer or something on site, we can load that material back into a truck and send it back to the plant, to the recycle pile. So just different things to think about as far as material spilling on the grade. Here's another one, folding the hopper wings, or in the bottom right-hand picture there, you can see the hopper flashing, the rubber belting on the front of the paver hopper isn't fitting well. So once that truck's dumping mix into the hopper, it's just all spilling out along the sides of the paver there as it goes along, cooling off and then getting compacted by the tires of the tracks on the paver before we pave over it. Folding the hopper wings, that's another one, and I'll talk a little bit more about that later, but it's just something that if we are folding the hopper wings as a paver operator, we want to be careful that we're not folding those hopper wings and spilling, again, that material in front of the paver on the grade. So lots of ways it can happen, and the big thing is to be aware of it and just understand or realize that there's a good possibility that's going to end up becoming a pothole or a defect in our mat in a year or so down the road. So just because it looks good right behind the screed doesn't mean that it's not there.
Odd.
Another one, when we get into pickup machines, if we're doing windrow paving and we've got a machine picking up off from the belly dumps or off the grade, those scraper plates that pick up material can be adjusted. You want to make sure they're adjusted so that they're getting a good clean pickup off the grade. So in this picture, you can see a thin layer of material being left on the grade there, not getting picked up and transferred into the paver hopper. And the next slide here is from a job I was on. I wanted to take cores and actually see the effect of what I thought was happening with that spilled material. So I popped some cores out where that material wasn't getting picked up clean. And on the base of this core sample in this picture, you can see the existing pavement, then the new AC or the new lift on the top portion, and the low density area where that material spilled. Again, cooled off quickly, so it never really compacted even after the rollers hit it. So what happens with that? Of course, water gets in there and the pavement just doesn't last as long as we're expecting it to last.
Odd.
So just,
Interrupt you for a second. Yeah, question. And I don't know if you'll cover this later, but if you do, then just let us know. But that material that's being dumped in front of the paver, are you going to talk about the pre-compaction that's being done on that if it's left with the trucks backing over it and the paver moving over it, and then the cracking that can or may occur?
Yeah, well, yeah, I wasn't really going to go into more on that, but no, that's exactly right. I mean, and that's what's happening there is that material is getting compacted with the truck tires or the paver tracks or the wheels, but it's not getting compacted to the degree that it should be, I guess is the with those, just because again, it's so thin, usually it's cooling off pretty quick. So it doesn't get compacted with the rest of the mat, so to speak. And then this slide here is kind of what you will see as a result of that. So yeah, I hope that kind of answered the question.
Yeah, it was more of the when you have excessive amounts that's, anywhere from 3, 5, 6, 8 inches deep, they leave it there, it gets rolled over. Then when the screed comes by, it chops the top off and gets it down to whatever placement thickness is going down. And then over time, and those usually are about, 10 feet long, where the truck is pulling away from in front of the paver. And then you come back, like you said, in not right away, you don't see it, but in a year or 2, 3 years, you see a 10-foot longitudinal crack in the wheel path.
Yeah, exactly. So yeah, good point. But yep, that's exactly what you'll likely to end up seeing. Yeah. And then I have to claim my ignorance here because I'm not sure what we do in Colorado for or for mix samples on the job, but some areas they do take plate samples, and that's another thing that can affect, to be honest, our mat quality to some extent as well. It does affect it. So I'm not saying it's right or wrong, but that's just something to think about and consider as well. So we're taking plate samples in this picture. I believe this was in Indiana on a job. That's what they require. But you've got to go back and do a lot of handwork and fill in that area where those plate samples are taken, and it's just not going to be compacted the same. So there's always a risk there again of having potholes or some defect show up later on. This one, raking, a little passionate and close to my heart on this one. So if you look at this picture, it's a bit of a rhetorical question, I guess, but what raker's doing his job? So you look at the guy on the left side there, and he's raking like a madman, and the guy on the right is standing there holding the rake, watching the paver place the mat, using the grade control there. So again, kind of a bit of a rhetorical question, but it's the guy on the left there that's really doing his job as a raker. He's there to make sure, if there is a problem or something along that joint, he can fix it if need be, but no need to really be continuously raking material along that joint if the paver is set up properly and the grade control is set up properly. And I'll show a few slides on that. But how does the raking affect the quality? And again, thinking mat defects. So longitudinal joints are a big deal. We've all seen so many roads that look great, and the longitudinal joints where it fails. This picture, beautiful looking mat all the way across, except for that centerline joint where it's separating or coming apart. So one cause of that, or possible cause of that, is the raking and the handwork on that joint. Something just to think about: is it normal for your crew to rake that joint while you're paving? Yes, no, sometimes, maybe. Again, I'm not waiting here for answers or responses, but it's something to think about. Are you doing it? Are you not doing it? If you are doing it, why are you doing it? And when are you doing it? And this is really the big thing here, is when you're raking that material along that joint, and I'm a human. It's a tough job, right? To do that all day long, walking beside the paver. So what do? Usually you set the rake or the lute down on the cold side, and you kind of broadcast it across the mat a little bit or bump it. But you're pushing material away from that joint, from that on the hot side, from the cold onto the hot. And now you've got less material there to get compaction. Doesn't look as nice. You can always see on the right side here, you can see on a joint that's been raked, you can always tell which lane was paved first, because you see that open texture on the other side where they kind of broadcast or push that mix across. There are a few situations where we get really large stone mix or something like that, or a bit of a height mismatch for a little ways, where we may have to bump that joint a little bit. But as a general rule, for the most part, we should be able to set up so that we're not having to rake that joint very, very often. So again, just a point to think about, if you're raking along that joint, or why do we rake it? It's basically if we have some, I'll call it a little glitch, or we have a localized spot that we need to fix a little bit. Maybe that's when we rake it, but it just as a continuous thing all day long following that paver is probably a better way of doing it. So how can we eliminate that raking? And I know I'm talking a lot about it, but I see it a lot as I travel around the country. I think we're getting better at it as an industry now, because we are seeing more emphasis on longitudinal joint density and specifications. But you have to have clean working end gates on the paver. And I'll show a picture of that. You want that end gate down on that first pass. So that's another thing I see a lot of times, that end gate's raised up in the air on that first unsupported edge or that first pass. And then getting a correct height match with the screed. So a lot of times we're raking that joint because we don't have a good height match with the existing lane. So when we pave the second lane, we're using the lute or the rake to kind of fix or feather that joint together, where we should be really using our grade control or using the machine to do that. So when you look at it here, end gates down, get a good square edge. Heated end gates may help a little bit. The biggest thing I think they do is just actually help keep the springs in this picture. If you look on the right side of that end gate, you can see those two sets of springs there. So when that end gate's down, those springs apply a little pressure, just enough to hold that end gate in contact with the existing grade. So as the grade changes a little bit, the end gate always stays in contact. It's not enough force to raise or lower, move that screed, if you will. But those springs, they get plugged up with mix. People don't clean them, so they just tend to leave them up and not use them or not put them down. So
That red, is that red line coming out there, the heater, they're putting heat into the end gate, or is that,
yeah,
is it just,
yeah. So that red line is, yeah, that's the high voltage electrical for the heat, screed heat, and on the end gate there. Yeah,
and that's not a standard feature, correct?
correct. Yeah, that's a heated end gates are optional. Yeah. And this is just a picture at the bottom there. You can see on the left side, sorry, that, you know, if you run that first pass with your end gate in the air, you get that mix kind of fluffs out at about a 45-degree roughly angle and tapers out. And then when you come back to match it, what happens? That mix tapers out to get that match. And then typically one of two things happens. That's when we end up raking that joint, because if I just leave it tapered, like you see in the bottom left image there, schematic, if I just leave it tapered and then I run over it with the rollers, it's going to break a bunch of rock, and the roller is going to be kind of teeter-tottering where you got aggregate or rock there and no thickness. So what do? We rake it, we push it off of that joint. Whereas on the right-hand side there, if you look in the bottom, if we have a nice square edge on that first pass, we come back and match it. Now we've got two good vertical edges there with a minimal amount of overlap on the top. Normally, not any raking required there. So this is just a little video clip just showing, you know, end gate down, springs are nice and clean, so they can do that. This is on a pretty smooth surface, but you can do this on a milled surface or other surfaces as well. But getting that first pass with those end gates down, and then getting a good height match. So here we're coming back now, we're matching that first lane. We got a nice vertical edge. That grade control sensor positioned where it is in line with the auger shaft is going to give those guys a perfect joint match as far as matching the height. And of course, they'll allow that height to have enough roll down. So typically we get what, about 1/4 of an inch per inch roll down. So in this case, if that existing mat was 2 inches, they would have that grade control set up so that new mat they're putting down would be 1/2 inch higher at the joint. And then after they roll it, now they've got a perfect joint match. So using the automatic grade control can really help with getting a good joint match and getting rid of having to do very much, if any, raking. And one more on this. This is just a picture, base mix, airport job. They're just running the single grade sensor right now to get a height match. Again, here you can see it's up in the P401 mix, 1 inch mix in this case, but they've got it high enough so that after compaction, they'll have a good joint match there. And coming in with the roller, same job there. Again, there's the first roller pass. I'd like to see a little more of an angle at the end of that pass, and then coming back. So this is only hitting it twice, and he'll come back and hit it a couple more times, but you can see they're getting pretty close to a really good joint match. And if they're not there, all they have to do is tweak the grade control up, you know, a few millimeters or down if they're a little too high after compaction. So lots of preaching on that, but I see it a lot, and it's one area that we can really get rid of a lot of mat defect. On that unsupported edge, talking from a rolling perspective, here you see about a 6-inch overhang on that edge. That's normally what I recommend to get the best joint density you can get on that unsupported edge, because that steel drum is rigid. The weight if you will, the force is acting straight down or vertically. And if I get inside that edge, I'll have a tendency to push that mix out. So most of our mixes nowadays are stable enough, they'll support the weight of that roller with a 6-inch overhang on that unsupported edge. Back in the day, before Super Pave, when we had round rock and pit run rock used in mixes, they weren't always stable enough to be able to do that. That roller might roll over a bit on that edge doing this. But nowadays, I'd say 9 times out of 10 or even more, the mix can support the weight of that roller hanging off that edge. In the few cases that it can't, then I would go inside about a foot off of that edge. But like I say, nine times or more out of 10, the mixes seem stable enough these days to support that roller, so you can do what Patty's doing here, and she's hanging that drum off the edge. You don't see the mat pushing or shoving out or anything. It's just giving her the best density she can get on that unsupported edge. And a couple more little clips. There's Dave on a roller here. He's overlapping, so he's on the hot side, hanging about 6 inches onto the cold on that first pass. Probably going just a little bit fast here, but he's hitting it from the hot side, about 6 inches onto the cold side. Want the highest joint density. He's about a foot, 6 to 8 inches, maybe as much as a foot inside on the first pass, all the way on the hot side. Now he's locking in that mix between the cold lane and the hot lane, and that little strip of mix now along the joint when he comes back to hit it. So there's his first pass all the way on the hot side. This looks like about a foot. It's going to vary a little bit depending on how thick your lift is and how much it's compacting on each pass, how far in you are with the roller. But he gets to the end of this pass, rolls onto the cold lane because he can, and then comes back and hits that area along the joint there. And again, in this case, joint densities, you couldn't tell the difference between the main line and of the mat and the joint. So when we just looked at the numbers on our sheet afterwards, without the location, you wouldn't know where they were coming from on the mat. Really good joint densities with that approach. But again, it relied on Dave, the roller operator, talking to the screed operator on the left side there to tweak the height. So they're using joint matching, automatic grade control, tweak the height a little bit to get the right match after roll down. So, and if you got a pneumatic, they're good at straddling that joint after the steel drums hit it, just for good joint density. So auger extensions, tunnels. So still talking mat defects. So we've got two situations when we get into wide width paving. We've got fixed width, so we're paving wide, but we're not winging in or out. We're just keeping it at 12 feet wide or 7, or I guess for wide width, we're wider than 12. We're keeping it at 17 or 20 feet or whatever wide width we're doing. So that's fixed width. And then variable width. So we're paving along at a wider width, but we've got to bring in the wings to go around obstacles, or our width is varying at different locations. So if we're looking at fixed width paving, again, the width is constant. We can set that screed up. It's got hydraulic extensions on it that wing in and out. And then we've also got bolt-on extensions that we can attach to the end of those hydraulic extensions, depending again on how wide we're paving. So the big thing here is having the auger extensions and the tunnel or mainframe extensions to match our paving width. So if we're set up on a fixed width paving, it's easier in the sense that I can run out. So this is a top view now looking down into the auger chamber. So we've got a front mount screed where the extension is in front of the main screed. You can see the screed operator's boots on the left side there, standing on the screed. But as we look down from the top, we've got tunnel extension in front of those augers. And we've also got auger extension going out to within about 1.5 feet of that end gate. So that's a front mount screed. On the right side, you're looking at a rear mount screed where the extensions are behind the main screed. So that mix tends to, it flows out off the augers kind of back at a 45-degree angle into that rear extension. So because of the nature of that material flow coming into that rear mount screed, we can get away with up to about 3 feet from the last auger segment to that end gate without having to have quite as much auger extension when we're on that rear mount screed. But we always want to have tunnel extension in front of the augers, regardless of front mount screed or rear mount screed. And that's what I'm showing here in this slide. So on the left side, you've got the hydraulic tunnel extension, then they put a little 1 foot bolt-on tunnel or mainframe extension so that they're not exposing any of the front of that auger. On the right side, that's how not to do it, by leaving auger exposed with no tunnel or mainframe in front of it. Because what happens is that mix will want to roll forward. It'll leave stripes in your mat, so it'll be a texture issue. And if it's bad enough, that can end up just being segregation. And you'll see the stripes in the mat behind the paver. So the next slide, I'm going to show a little video clip. You kind of have to watch the mat coming out behind the paver. I think it's maybe a little hard to see, but definitely overloaded here, right? And the worst part about this one is this was fixed width paving. These guys weren't variable width. They weren't bringing that wing in or out, but they have to really overload that extension to get enough mix out to the edge because they didn't have enough auger in there or tunnel extension. And I know it was a bit of a quick sweep back there in the video, but all that mix in that screed extension there was causing a lot of texture issues. And again, you're even going to get segregation because what do big rocks like to do? They like to roll out into the corner of that screed, right? The screed and the end gate. So always want to get tunnel and auger extensions out there whenever you can. And the time it gets tricky is when you're doing that variable width paving, because you can't have auger extension or tunnel out there if you're going to be bringing that wing back in. That's when you really need to have somebody ready on the shovel to shovel mix out there when you're going wider, to minimize or eliminate segregation going on by overloading that screed. Another thing I wanted to kind of hit on, so in this picture, if you look closely, you can see chatter in the mat. And I think originally, at first, my first inclination was to blame the rollers, but you look at that chatter and it goes all the way across the mat. So a roller isn't the full mat width. So right away, that tells me that's being caused by the screed, right? So that's going to affect our smoothness. It's going to affect our density when we get there. What's causing it? Could be a high angle of attack on the screed. So maybe typically we want to run at a 1/4 inch angle of attack. We could be running too high, and I'll touch on that some more later here. Maybe dirty pivot points on that screed. So I'm just going to show a little couple pictures coming up on what I'm talking about there. But the pivot point on the screed, so on the right side, you see the toe point. That's connected to the paver or the tractor. That's a pinned connection. Then the yellow there is the toe arm, goes back to the screed, and then the drop arm goes down to the pivot point. And that red dot on the screed is that pivot point. So that screed can rotate around that pivot point. But what happens sometimes is if we get too much mix in there, and I'm just skipping ahead one slide here. If we get too much mix in there because our screed was overloaded, and that's really the only way it can really happen. But if we get too much mix in there and it gets down in where that drop arm goes down to that pivot point, it plugs it up. Mix gets in there, it hardens up, and then that screed can no longer freely rotate around that pivot point. And then we end up getting chatter in the mat, because we're trying to fix it by running too high of an angle of attack, when the real problem is material down in around that pivot point, not allowing that screed to rotate around that pivot point. This is just a picture looking down in where that drop arm goes, and that pinned connection is down there. It's hard to see in a picture, but it's buried under that cold asphalt mix that got down there. And the only way to get that out is take that cover plate off the side and just clean that mix out of there, so that pivot point is free to rotate. And if you're on the paver, you know it. You go to turn the depth cranks, the screws, and you can't turn them very far, or they're super tight. Good chance that maybe you've got mix down in there that just needs to be cleaned out, because screeds will get overloaded, mix will get down in there. It's not what we want, but it's usually a matter of time, and it will happen at some point. So we just got to make sure they're good and clean. And there's different ways of doing it. I've seen people put little bits of conveyor belt on there to help prevent that mix from getting down in there. In a perfect world, we're not running the mix that high to get down there to begin with, but it does happen every so often. And we talk about mat defects, thinking about the paver set down and takeoff. So I just mentioned that angle of attack and chatter in our mat. So being a defect, if we're getting chatter, that's affecting our smoothness. And in my world, that's a mat defect. Even though it's not necessarily a visual one, you're going to feel it in the ride. But we do a lot of our training. A lot that I do is what we call our paving by the numbers, and it's just a 15-step procedure. So it's kind of like, once you get used to it, you just go through it, and you don't even consciously think about all the steps. But you do these steps consistently, religiously, every time you set down that screed to take off, to get a good, smooth takeoff at the right angle of attack with that screed. So I'm not going to go through all these, but what I would like to do is just hit on a couple of what I'll call the big ones in those 15 steps. And one of them is step number 2, setting our toe points before we take off. The big thing for that free floating screed to put down a nice smooth mat is having what we call a straight line of pull. So on the picture on the right-hand side, you've got your toe point up there where that screed is being towed or pulled by the tractor. So that's the pinned connection. We want that to be parallel or in line with that pivot point back at the screed, back at the screed there that I was just talking about, that can get plugged up. So we want those in line. We want what we call a straight line of pull when we're paving. So setting that toe point to the right height based on the thickness of the mat we're paving. So it's not always going to be at 0. It's going to depend how thick we're paving. But the goal here is to take off with that straight line of pull, where that pivot point and that toe point are in line or parallel with each other, if you will. So again, I'm not getting into the details of this today. It's a separate little training event, but setting that toe point to get that straight line of pull before we take off is critical. Because if I don't, I'll try correcting once I get paving, and that's again where I may be running a higher angle of attack than I really want to be, and that can end up giving me that chatter in the mat. So that angle of attack, it's the relationship between the nose of the screed and the trailing edge. So a little bit of nose up attitude. Again, we want about a 1/4 of an inch angle of attack while we're paving. So we're setting that up before we even take off by setting our extension, our extender height. So again, not going through all the paving by the numbers, but this is step 5 in the paving by the numbers. Set our extension height before we set that screed down to take off. And that extension height is what's going to establish my 1/4 inch angle of attack. So on a rear mount screed, I'm setting it at a 1/4 inch before I put the screed down on the starter boards. On a front mount screed, I would set it at a 1/4 inch below zero, my extender height. And what that's going to do after I null out and everything is ensure that I'm paving at a 1/4 inch angle of attack. Why does that matter? Because if I go back to the screed here, if you look at that screed plate all the way from the nose or the front all the way to the back, it's all that screed's free floating. The only thing holding it up while we're paving is the mix underneath it. So the more plate I have in contact with the mix is better flotation. The screed's going to float better. I'm going to have more control over it when I change thickness or when I change slope. And if I have a really high angle of attack, again, going back to the chatter, I'm only riding on the tail or just a little portion of that screed plate instead of all 36 inches or of depth or whatever it is, depending on that screed. So again, if I got a really high angle, I'm only riding on the last 12 inches and I've got 36 inches of screed plate there. So a lot of pressure in a small area. Screed, it's like an airplane wing. It's going to go chatter, 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 and leave those bumps. So that's why this angle of attack is really, really important, because it's ensuring that I'm using all of my screed plate and getting good flotation. And the boards, so the starter boards that I put underneath the screed. So when I sat down to take off paving, I got to set that screed on something, whether it's an existing asphalt or in this case, starter boards. The big thing here is to make sure the boards that I set down on are 3 to 4 feet long, because on the left there, I want those boards to go all the way from the nose of that screed, the face of it, all the way back behind the trailing edge. And that gives me full support of that screed when I set down before I take off. If I just use a little piece of rock or a pop can or something like that, I used to be the guy, Todd, go find a pop can in the ditch or a couple of rocks about the same size and set the screed on. If I set it down on a little board or a little whatever that doesn't go all the way underneath that extension and the main screed plate, that screed, when I take off from my starting boards, it's going to want to nose over or roll over on me. And that gives me my bump when I take off, or my dip. So really important to have full length boards to go underneath that screed before we take off. I'm going to show a little animation here and then we'll get into some other mat defects. But this is that getting ready to take off. So setting that angle of attack. So here's my screed. This is a rear mount screed. So I raised my extension 1/4 inch above zero. Because what angle of attack do I want to run at? I want to run at 1/4 inch, right? So I raised that extension. Now I set the screed or float it onto my starting boards. This is why those boards need to be that full length. So I pull the slack out a little bit at the toe point. Now I'm going to null out. So this relaxes our screed before we take off. And when we do that, that screed just rotated around the pivot point, rotated back. And how far back did it go? It rotated back 1/4 inch because that's where I set that extension height. So now the screed's totally relaxed. I'm going to fill it up with mix and take off and start paving at 1/4 inch angle of attack. So the next 2 little things here I just want to show are what I see common mistakes in the field. So we're screeds up in the air, step 5, paving by the numbers. We raise it up, raise the extension up 1/4 inch. So that's all, life's good. Now we're going to float the screed onto our 4-foot starting boards. Oh, here we go. Press the float button. Screed comes down. Pull out that little bit of slack at the toe point, just inch forward. Now we're going to null out again. So turn our depth screws on the right and left side to relax that screed. So it rolls back what? Again, it's 1/4 inch, right? So that's good. This is, same thing we already did on the first one. But now the difference is that first one, we relaxed it, rolled it back, and now a buddy on the screed here thinks he needs to put 3 or 4 turns into it. So what did we do? We were at a 1/4 inch and relaxed, and now I just put 3 cranks into that screw. I don't know what angle I'm at now. All I know is it's more than a 1/4 inch, and I've got all that pressure on that trailing edge of the screed. I'm going to ride, once I take off, I'm going to be at a high angle of attack, a lot higher than a 1/4 inch. And then the last one I just want to show here, they just skipped step 5. They didn't even raise the extender height. They just dropped the screed onto the starter boards. So there's no angle here, right? And now after they take that little slack out, they're going to null out, relax that screed. It's nice and relaxed, but there's no angle of attack in there. I can guarantee you're going to have a nice, really open textured mat, because it's going to drag and kind of tear the mat, if you will, once you get paving. And it's going to be hard again. Think of the screed like an airplane wing. And they know that, so what do? We put a bunch of cranks into it, and now we don't know again what angle of attack we're at. All I know is it's high and all riding on that trailing edge. So think of that screed again like an airplane wing. It's got to have mix coming under it, supporting it, but again, it's got all that pressure on that trailing edge. In this case, it's going to be like chatter, chatter, chatter. Okay, lots of that, but switching gears, managing mix in the hopper. So we look at the hopper level here, we're empty, right? Not good. So whose responsibility is it? Paver operator, dump person, truck driver, doesn't matter if it's full of mix. I'm going to say it's probably the paver operator and the dump person are the 2 main people looking at that hopper level. Why do you care about it? Because if you get that lower hopper level, what do we get? We get segregation. Where do big rocks always want to roll to? They want to roll to the outside edges of the hopper. They want to roll onto the chains or the conveyors in the middle of the hopper that are taking the mix back. So if we run that hopper level too low, we end up with segregation. That's going to affect our smoothness, our density, our durability of that mix because it's segregated. And head of material. So every time we run that hopper low, it's affecting the head of material or the amount of mix back at the screed. That's going to affect our smoothness as well. Here's a classic end of load segregation. Every truckload can pace it off 20 paces. I see what I'll call a rock pocket. And like I say, they're just equally spaced. I can tell that paver operator ran that hopper low at the end of every truck. So when we look at segregation, what do we get? Generally, we got 3 kind of main types. We've got patch segregation, we've got stripes. So those would be continuous type stripes that we see in the mat. And then the hardest ones to kind of troubleshoot are the random patches that we see. So continuous stripes or regular patches like that end of load, those are a little easier to troubleshoot. It's the random ones that don't have any even spacing, if you will, or pattern to them that are a little more difficult to troubleshoot. So when we look at truck exchanges, that's important if we're end dumping into the paver as far as managing that hopper level. So here you got the paver pushing a truck. It's really, again, I think the operator, paver operator, and the dump person, if you have a separate person dumping trucks, a lot of times that is the paver operator giving signals to the truck driver when to raise and lower the truck bed and when to pull away and all that. But working together, good communication, understanding the signals, for raise the bed, lower the bed, and when to do that. But it's really that truck exchange, if we're end dumping, it's really what I think of as a 4-step procedure. So step 1, we're paving along. We've got a truck up there. All the mix is now in the hopper. So as soon as that bed or that truck's empty, we're going to release that truck. So give them the signal, truck's going to lower the truck bed and pull away. As a paver operator, we're gonna just do what? We're gonna keep paving at our normal paving speed. So not slowing down and then speeding up, because that's going to affect our head of material and our smoothness. So we keep paving at our normal speed. Step two, we're paving along as that truck pulls away. We're gonna keep going until that mix level gets down a little bit in there. If we are folding the hopper wings, we can start to fold those wings as long as we have enough mix there where we're not exposing the slat conveyors or the chains or the tunnels in the paver hopper. Large stone mixes, 1 inch and bigger, generally not a good practice to fold the hopper wings segregation wise. But if we do it real carefully, we can do it without spilling on the grade in front of the paver and without sacrificing our head of material or getting segregation in the hopper. So next truck's getting in position as we're paving along. In this case, the paver operator's folding the hopper wings carefully, so he's not, I do see a couple little rocks on the grade there, but he's not spilling a bunch of material on the grade and then bringing that mix in toward the middle while still keeping those conveyors and funnel openings covered with mix. So there's your large stone mix. Again, generally probably a better idea when you're in 1 inch or 1.25 inches, 1.5 inch base mix like this. Probably a better idea not to be folding the hopper wings. Just have to shovel them out periodically or even clean it out at the end of the day. So we're going to get to a point where on that truck exchange, got a little bit spilling out here. We're going to stop. So what we've found, and we're going to stop quickly. So I mentioned earlier, truck releases, we're paving at normal speed, going to let the hopper level get down a bit, but we're going to stop before it gets down to the point where we're seeing seeing the chains or the tunnel openings. Because again, that's segregation and head of material when we start seeing the tunnel openings. That mix, now the paver's made a quick stop. So let's just say it was paving at 30 feet a minute. I'm just picking a number. So he's paving along and now doesn't want that mix to get all the way down. Next truck isn't right there yet. Quick stop all the way to neutral. Once that next truck gets in position, stops just short of the paver. Paver's gonna go full speed, full propel, right back up to that 30 feet a minute. And the key there is, when I first got into paving, they said the best paver operator never stops the paver. You keep it moving, you keep it moving. And we didn't measure IRI back in the day. We kicked a 10-foot straight edge, or maybe every once in a while we had a 25-footer we pulled out and checked our smoothness or our longitudinal profile. And it didn't pick up those little dips. But you look at IRI now, and I'm sure there's people here understand it a lot better than I do. But you're looking at 100-foot wavelengths, 30-meter wavelengths now, and it'll pick that up. And as soon as that head of material drops in that at the screed, then that happens. If we're slowing down gradually and speeding up gradually, that head of material changes a little bit. That screed's going to do the same thing. It's going to go down a little bit and up a little bit. They still seem pretty smooth, but we've found better smoothness results and dumping if you make that quick start and stop in between truck loads. And this is what you don't want to do. Again, you don't want to see the tunnel openings or the chains. Again, segregation. What's the first thing that's going to come through there once I get more mix on top of it? A bunch of rocks, right? I'm going to have that rock pocket. And that's your end of load segregation when you do this in between truck loads. And what's the other big thing, and I feel really bad showing this video because these guys did an awesome job on smoothness, and I just happened to catch them one time during the whole day. but that truck backs up and you want that truck stopping just short of the paver, right? Not bumping into it like that. And what happens if it's bad enough or a big enough hit, if you will, when that truck backs up, it's going to push that screed and leave a mark, a screed mark that if it's bad enough, that's not going to roll out. It'll still be there even after compaction. So what do? We bring that truck in, we stop it just short of the paver, a few inches short. Dump guy there's got good hand signals going, stops them short, and then the paver's going to go full propel back up to paving speed and pick up that truck. Windrow paving, big thing here, because again, I'm thinking about segregation and smoothness. So in the top left, if I've got a bone pile at the end of my windrow coming out of that belly dump, what's the pickup machine going to do? You're going to have a bunch of rocks. So even though end of load, you can have it with end dumps, you can have it with belly dumps. So really critical to overlap those windrows. That's going to minimize or eliminate that segregation happening, the rock pockets, and it's also going to help you maintain that good head of material back at the screed for good smoothness. So also overlapping the windrows, couple truckloads strung out at the most, as far as just thinking temperature management here in terms of density on the job. So a couple truckloads generally at the most ahead of that paver. Have the other one staged and a rule of thumb I've just kind of found, I mean, if the paver's going to sit and wait for a little bit, it depends on the weather, the ambient conditions, how fast that mix is going to cool down, whether we actually have to pick up and set down again, build a transverse joint if we're going to sit for a long time. But a lot of times if that hopper is full, you know, we might have up to as much as a half an hour where we're still not going to be perfect, but where it's going to hold heat in there. A full hopper is going to hold heat better than a hopper that's almost empty or getting low. So if we got to wait a little bit, we got to wait a long time, best thing, pick up and set down again when we get the next trucks in. But that's just showing, keeping the windrows fairly short, no more than a couple truckloads ahead of the paver or the pickup machine in this case. So the proper level, just enough to cover the conveyors, tunnels, generally that's about a third to a half full on there. So there's a couple pictures on the left there, pretty good. You know, you still got mix in there. You haven't exposed the chains or the tunnels. We're waiting, that next truck's backing up to the paver there. And then on the bottom right, folding the wings, tunnels, chains, everything's exposed there. That's going to be a rock pocket. Now this slide, I just wanted to show again. So what I see a lot, run that paver down. So if you look on the left picture, if you look back at the screed on the left side there, there's a whole pile of mix back there. So they got lots of mix back there, nothing in the hopper, right? So when that next truck comes in now and dumps on into the hopper, what's the first thing that comes back on the chains? Probably a bunch of rocks and a bunch of air, right? There's nothing in there right now. So as soon as that comes through, head of material, the amount of mix back at the augers is going to drop and that screed's going to drop. It's going to put a dip in our mat. But we're pretty smart. You know, we know this is going to happen because we ran the hopper right down. So what do? We dump that truck in the right, we dump it in there. And then what do? I hit the manual overrides and I fill up that auger chamber and the chains and the tunnels, right? Generally have a tendency to overfill it when I do that. So I bring too much mix back now. And then what happens, I take off that head of material. I've got a big head of material there and that screed does a little rise up on me and then comes back down again. And there's my bump. So very, more common than I would like to see, but very common. I'll see this and it'll be, you get the little dip and then the bump, dip, bump, dip, bump by doing that. And it all goes back again to this head of material. So the amount of mix back at the auger chamber, right? So as long as it's consistent, the feed coming back from the hopper, and we're going to have that consistent head of material. Because remember, that screed is free floating. The only thing holding it up while we're paving is the mix. So every time the mix height in the auger chamber, that head of material, every time it changes, it drops, screed drops. It increases, screed goes up. So consistency is the key word there. And that's how this all relates back to what's in the hopper and what's coming back from the hopper. So how do I manage that head of material? Got conveyor ratio dials. I've got auger height that I can set on the paver, on the machine. Got auger speed, and then aiming my feed sensors. So those four things are really the tools I have to control the head of material or the amount of mix back there. I just thought this was kind of a funny picture because they are paving wide. Looks like they were just paving wide all day here. So, but for whatever reason, no auger extension, tunnel extension to be out that wide. And they had to feed enough mix out there, way overloading the screed in the center just to have enough to get to the outside edge. So what did they do? So it didn't spill over the back of the screed. They had to get a nice piece of metal, and they picked the oversized load sign off the low boy and put on there. I just thought it was funny because it says oversized load, and they've got a oversized head of material. But there you go. Those are the four things. I'd say 95% of all mat defects are related to managing that head of material. These four things right here. So I'm going to hit on them quick. Mix level at the center of the auger chamber. So that's, again, my half auger height head of material. I've got conveyor ratio dials in the top left. Those are up at the paver operator's control. So I use those dials to change the speed of the conveyors to bring more or less mix back to the screed. And the bottom center picture is on the older model pavers or some of the smaller commercial pavers. Instead of those variable speed conveyors to bring the mix back, you've got flow gates. So the conveyors, the chain speed is constant, but I can raise or lower those flow gates to regulate how much mix is coming back to the auger chamber. So two different ways of doing the same thing depending on the paver you have. There's just a view in there for anyone who may not be familiar. There's your hopper chains or conveyors, and then looking through the tunnel there, you can see the augers back there that spread the mix across the face of the screed. Then I've got auger height. So general rule of thumb here, this was in our paving by the numbers, but we want the bottom of that auger flight to be about 2 inches above our mat while we're paving. So another kind of key thing, most crews are pretty good about this, but if that auger's too low, I'll have an open textured mat and I'll be starving that screed for material. So it won't want to float properly. And I'll be fighting it by trying to make adjustments with the depth screws. And then I'm generally running at a high angle of attack and having mat quality issues that way. Open texture, maybe good risk of chatter in the mat. If I got the augers too high, then good chance I'm just carrying a lot more mix or a lot more material back there than I really need to. So general rule, about 2 inches above the mat I'm paving, and that can be tweaked up or down a little bit. The other big thing is 20 to 40 RPMs for auger speed. So if those augers get going too fast, they're going to segregate that mix. You're going to see the rocks, the big rocks kind of flying off the end of those augers, and you're going to see stripes in the mat texture. So again, about 20 to 40 RPM, there. So if I count 1,000, 1,000, that's 30 RPM. I'm right in the ballpark of auger speed. But yeah, if they get going too fast or too slow, if they're stopping and starting and not turning, that's going to leave us stripes and auger shadows in the mat as well. So speed is important. I'm going to use those conveyor ratio dials or those flow gates to help me actually control this auger speed. If they're going too fast, I turn up the dials, I bring more mix back. The auger doesn't have to work as hard to get the mix out to the end gate. So I can slow down the augers, or I can speed them up by slowing down the conveyors coming back from the hopper. Brings less mix back. Now the auger has to go faster to get the mix out to the feed sensor at the end gate. So getting in that 20 to 40 range. The only way I can do that is if I have my feed sensors aimed properly. So these are sonic feed sensors. It's probably 90% of what people are using nowadays. There are paddle sensors. I'm not going to get into those today, but they do the same function. But these sonic feed sensors are controlling the amount of mix at the outboard end of the augers. So they're sonic. They send sound waves, measure distance from the sensor to the mix. And as I adjust the mix height dial on the screed, that'll raise or lower the amount of mix back there. So having these aimed well, number one, I want to be about 18 inches away from the mix and about 18 inches away from the last auger segment. Kind of a sweet spot. I also want to hit the mix about perpendicular 90 degrees. They're sound waves. So if I don't, they come back to the sensor to tell it what distance it is. So if I've got it off at a steep angle, if you will, to where that mix is, some of that sound wave or sound signal gets lost in space, and they're just not as accurate. You don't have as good a control. So aiming them properly, really important. This is just a bit of a picture showing that. So on the left, can't really see it in there, so I apologize, not the best picture. But that's your feed sensor aimed perpendicular 90 degrees to the way that mix is flowing off of the augers into that rear mount extension. On the right side, that feed sensor, I'm kind of trying to show using the arrows there where the beam or the sonic wave is hitting from that feed sensor. So again, about 18 inches from the sensor to the mix and about 18 inches from the auger segment out to where it's hitting the mix. So it's kind of a sweet spot there. You got to move it around a little bit. And the easiest way to do it is walk beside while they're paving and loosen the little wing nut on that feed sensor and just move it until you see that auger turning continuously. If the auger is starting and stopping, start, stop, that feed sensor's probably aimed straight down at the grade. And that mix is rolling forward. It sees the mix and it shuts the auger off, and then the mix runs down a bit, and then the sensor doesn't see any mix, so it tells the auger to come back on again, and that's when you see the augers go on off, and then you see stripes in your mat behind the screed where that auger's turning on, turning off. In this picture, you can also see. Looks like the augers were probably going pretty fast, the way that mix is kind of flying out around that tunnel extension there. But aiming those feed sensors is really critical. I see a lot of crews just point them in one spot or point them straight down and just leave them there. And you get that on-off auger. And this is just a picture showing a little bit of matte texture on the right-hand or left-hand picture, where you can see a different texture in that mat. And it's could be, if I'm just standing behind looking at it, first thing I'm going to go is check those feed sensors and see if the auger's turning continuously. And if it is turning continuously, and I'm seeing matte texture or segregation on one side, another thing I could look at is in the truck. If I got coarse mix on one side of the truck and fine mix on the other, maybe it's an issue at the plant, right? Their batchers or loading out coarse on one side of the truck, and it's coming from the truck through the paver and being open textured or segregated even on one side. But first thing I'd look at is check those augers are turning constantly, then go look in the truck and maybe trace it, if it is that, back to the plant. I talked about the quick starts and stops earlier during the truck exchange. So if I'm doing truck exchanges, I'm going to make those quick starts and stops. Sorry, I'm just checking my time here. So I'm getting down. but those quick starts and stops are going to be our best friend for smoothness. So pulling off the starting boards quickly and then coming to a quick stop if and when we have to stop the paver. Once we pull off the boards, one of the most common mat defects I see are these longitudinal lines. So in the bottom right there, you see two images showing those lines, and I'm going to show a picture in the next one. But these longitudinal lines, I see them a lot. They drive me nuts, and they're usually an easy fix. So in this case, there's separation marks. So you've got your main screed fixed with, and then you've got the screed extensions. I follow that line and see where it ends up. So if I follow the line where the yellow arrow is in this picture, and it's inside the width of the main screed, right? The fixed main screed. So it's the inside edge of the extender, the extension that's causing that. It's a height mismatch between the extension and the main screed. So what it's telling me, because it's on the inside edge, is that that extension is lower than the main screed a little bit. It's cutting in or leaving that line. So what I have to do is hold the screed, the extension height button. There's an up and down arrow. So you got one button to raise it, one button to lower it. I'm just going to hold it. It moves really slow and raise that extension until that line disappears. And once it disappears, I'm good. And it's usually just takes a few seconds to get rid of that. Another mat defect, roller bumps. So roll right off the mat whenever possible, right? Instead of stopping on a hot mat and leaving roller bumps. If I've got room or traffic control allows it, these guys on the highway here in Minnesota, they just rolled off onto the cold mat at an angle to actually stop and change direction. It's not always possible, right? Because we're on areas where we don't have the room, we don't have the lane open or adjacent area, or we're on the first pass where we can't roll off that edge. So, but when possible, it's a good one to do. If I have to stop on a hot mat, these guys have nowhere to go, right? They can't roll off that edge on the first pass here, or on that unsupported edge. So when they do have to stop, in this case for a water fill, stop as far back as possible on the cold mat. Less chance of leaving any roller bumps in your mat. What these guys did was they were on a smoothness job upstate New York, and they were getting dinged a little bit on their IRI. They had the roller bumps, and long story short, they figured out when they were stopping to fill up with water, the roller was sinking in the mat a little bit, leaving marks. So what they did was got in the habit of stopping further back to fill up, and in this case, parking on the shoulder, because they're not measuring IRI on the shoulder. They had to actually get a longer water hose for the truck so they can do that. But you guys all know it's a lot of money in IRI penalties if you're getting dinged on these. I think all I'm showing here is just coming up to a stop at a turn or at an angle at the end of the roller pass. So that's another big thing. Why do we want to stop at an angle? Because those marks will roll out, right? So at the end of a roller pass, the next little video clip here is going to show you how not to do it. So here we got the roller coming up, stopping square on the mat. And what happens here, it pushes that mix forward, and the mix builds up in front of that roller drum. And at some point, that roller is going to come along, hit that same area and go bloop up and over that mix that it's pushing forward here. You can really see it in the bottom right. And then once it goes up and over that, there's our bump in the mat. So our best practice here is to shut the vibe off and then come to an arcing stop or stop at an angle. And then when we come back on the next pass, we want to just roll straight through this area, because vibe is off now in that last 20, 30 feet or even more, where we shut the vibe off before we come to a stop. So we want to make sure that gets vibed. So the next pass, we don't stop in the same area. We go straight through with Vibond and then do the same thing just a little further down the road. So it's like a constantly moving starting stopping point, if you will. So be careful not to stop, even at an arc. Don't stop in the same spot all the time, or you're still going to have a bump, right? But when we stop at that angle, when we do roll through it straight through with the Vibond, because it's at an angle, that mix has got room to move laterally, and you don't build that mix up in front of the drum and get that bump in the mat. Another thing, roller speed. So chatter in the mat can also be caused by rollers. 10 to 14 impacts per foot is our recommended range, and it doesn't matter. I think almost all, if not all, the highway class rollers on the market today have gauges on there that either tell you if you're in that 10 to 14 impacts per foot range, or you can go in there yourself and actually select it as, I call it cruise control. But you can go in and set it so that when the roller goes full propel, full speed, it's limited to that 12 impacts per foot in this case. So you can't get going too fast and end up having chatter and bumps in the mat. Tender mix, that's one thing sometimes we deal with, and I think this will be my last topic here, and then we'll close out. But if you get that mix that's pushing and shoving underneath the rollers, nasty. It's kind of hard to see here. I'll see if I can replay it one more time. But look closely at the mix in front of that drum. You can already see it's kind of ripped or torn there along where that roller drum went, but it's pushing and shoving. It's not compacting. And there's two reasons main reasons that I see tender mix. Could be a bad mix design or just not a great mix design. That's generally not the case. Most times it's moisture in the mix, didn't get fully dried, and that moisture is getting released in the field. So we get it mixed at the plant, the rock's got moisture trapped in it now, and it's literally, as that mix is being transferred from the plant, whether it's into the silos and trucks or straight into trucks, that trapped moisture in the aggregate that didn't get fully dried is now getting superheated as the heat gets from the outside of that rock toward the center. It evaporates and that moisture releases, and then it's just like trying to roll on marbles. And typically, if we have tender mix, it'll be in a range or a zone that you kind of have to identify in the field. So it may be a typical number might be 230 down to 190 degrees. It's pushing, shoving, all that. Anything above that, it seems fine under the rollers. Anything below that 190, it seems just fine under the rollers. But in that tender zone, it can be a nightmare. So again, maybe mixed design, and I do see that sometimes. Sometimes our specs force us toward tender mix designs based on our job mix formula. But most times it's just moisture in that mix. Another one here, if I look at these pavers, so here in the top left, 20 or 25 feet wide, I can't remember, but you can see a completely different mat texture behind those bolt-on extensions. So it's hard to see in that left-hand picture, but the shiny tubes is your hydraulic extensions. And then beyond that, going out on each side, you've got bolt-on extensions to get to that 25 feet on an airport job. And the bolt-on, completely different mat texture, as you can see. And what that's telling me is those bolt-on extensions are nose down. So they just, long story short, they weren't installed properly. They need to be adjusted to get the same mat texture all the way across. On the right-hand side, again, you've got two different mat textures going on behind the main screed and behind the extension. So there's adjustments that can be made, should be made to fix that. If you're seeing that all day long, you want to make some adjustments. I hate hearing, it'll roll out, right? Mat texture usually doesn't roll out, but it should look the same all the way from one end gate to the other. Paver stops, there's another mat defect, right? If we have long stops, again, this is just kind of our numbers, our research, if you will. When you start getting stops longer than about 6 minutes, you're going to end up with differential compaction. You're going to have bumps. This is the same image on the left and right side, one just showing, taken with a thermal camera. But if you look at the temperature zones, you've really got 4 zones going on when you have those long stops. You got the temperature under the catwalk of the screed, because the roller can't get right up under there when the paver's stopped. And then under the screed plate, 266 roughly. Under the catwalk, 190, because it's not covered. It's just exposed to air while we're sitting there for a long time. In the auger chamber, you've got mix in there because we left a head of material in there, but it's down around 240. And then coming back from the hopper, once we finally get started again, is about 260. So you got that whole zone there. I'm just gonna, I don't know exactly, let's call it 20 feet. That you've got these 4 different temperature zones going on with those long paver stops. Short stops aren't gonna kill you, right? It's the longer paver stops that are gonna cause problems. So in summary, I think to kind of simplify it, avoid all the stuff I talked about today is what I call basics, right? So avoid the big mistakes, I call them. The long paver stops, the spills on the grade, running that hopper low, so that's segregation, head of material. With the rollers, 10 to 14 impacts per foot, that pay attention to the truck exchange. So again, in between trucks, not running that hopper low, avoiding spills on the grade, and being very conscientious about folding the hopper wings. So I'm a big believer you can do it if you do it consistently and don't spill material in front of the hopper when you're folding the wings. Managing that head of material at half auger height. So again, you got 4 ways of doing it. You got your conveyor speed, your feed sensors, your auger height, and your mix height dial. Bumping the paver, so just let the paver pick up the trucks. And then with the rollers, again, stopping at an angle on the mat, not stopping square on the mat. And whose responsibility is it? Again, I always like to say, if it's everyone's, it's no one's. So some of it's equipment maintenance and cleaning. It's at the paving crew, probably at the end of the day, cleaning the springs on the end gates is likely the paver crew. Other stuff would be the shop. But it's really teamwork and communication, right? And you own quality. I mean, you're the one in the field on the job. So it's the teamwork, the quality, and the profit. Doing the fundamentals right, being consistent, avoiding those big mistakes. And I always like to say talking to each other. And it's everybody involved, right? Not just the paving crew, it's not just the plant, not just quality control, it's everybody involved, including the inspector on the job. So quality costs nothing, right? None of what I showed costs any money. It just costs paying attention to detail. So I've got a compaction troubleshooting chart and a mat defects troubleshooting chart. I'd be glad to share those with Tom, or they'll be if you guys want those. So that's all I had today. I want to thank you very much for your attention, and I'm here if there are any questions or anything to follow up with.
Anybody have any questions out there? You can either unmute yourself or pop them into the chat window. We would be happy to answer those questions for you. Do appreciate, Todd, all the information. I mean, that was a ton of information that you presented for us. Kept everybody on. We only lost 1 or 2 during the time, so that just means that you're giving us the good information. I did get somebody say they want copies of those charts, so if you could send those over to me, I will then get them available, make them available to anybody. Just for everybody's reference, this was recorded. So if anybody does want to go back and look at it again or give it to some of your fellow employees, You can get the video. Yeah, you'll get the video. It will be available on, the question just came in, can we get the video? But yes, you can get the video. It will be available on the Kappa website under the RMAEC tab under archived webinars. It won't be probably until Monday, as when we get done here, I'm going to walk down, get in my car, and I'm heading out of town for the weekend. So I'm not going to get to it today, but I'll get to it Monday morning, and I'll have it up there for everybody. So Bruce, I see your message. You want the charts as well. So I'll get those charts. I'll make them available. What I will do is I will go back to everybody that's registered for today, send out an email. I'll include those charts, or just tell you where I put them. Actually, I'll probably just tell you where I put them on the Kappa website. So, and you're okay with that, Todd, if I put them on the Kappa website?
Yeah.
On our library
Yes.
resource page?
Yes. Yeah.
Okay, yep, have a bunch of people that would like those. So, all right, I'm not getting any other questions other than the people saying the same thing that I've said. Thank you very much, Todd. We really appreciate your time and expertise in putting this thing together. I know it's a lot of work to do, and we do appreciate what you've done. Again, I want to thank all of our sponsors. You can see them on the screen. Thank everybody for being on. We got several more webinars coming up yet this year. So just keep your eyes peeled. We publicize them twice a month. They're also publicized on the Asphalt Pavement Alliance website as well. So Todd, again, thank you. It was great to see you last week.
Yeah.
Todd and I were in Kansas City together, and looking forward to seeing you again soon.
Yes. Thank you, everyone. Thank you, and have a good weekend and be safe.